1, 3, what's its vector to 0, 0? It's 4 minus 1, 3, its distance. So to turn it into a vector is quite, you can think of it as a point or a position.
So R is point B. R is point B.
Or is point B, I don't understand. Okay. B then is a direction vector. So it's saying from there what distance and, the distance will be determined by lambda, but what direction we're going in. Okay. You may be able to notice that a line or a vector equation, it will not be unique to a particular line, will it? Does that make sense? As in, this line could have more than one equation. It just, if we had used a point down here, then its position vector would automatically be different. And its direction vector could be just the opposite direction. So it could be a minus instead of a, so they all could be, I haven't done a direction vector. I'll do an example in a second. So let's do an example. I think it's much easier if we see some numbers. But before we do that, I want you to look at this. I think I already have this. That's just what I've done. That starts to look a lot more complicated. So there's 3 ways of discussing vector equations. This is what I've done is the vector equation. The other one is a parametric equation where you look at each. So each of these is a vector. Let's look at that. Or is A plus B. A would have a vector component. I'll stick with the letters they've used here. A1, A2, A3 plus lambda. Yes, I'll use this. B1, B2, B3. That could look like with actual numbers 2, 4, minus 1, that's our position, plus 3 times the direction of that position might be 5, 7, and 2. This is just an example. That we can split this up into a number of parameters. We look just at the x parameter let's just keep it as lambda. X parameter would be 2 plus 5 lambda or lambda 5. That would just be looking at the x axis. And the y then would be 4 plus 7 lambda, based on this, and the z direction would be minus 1 plus 2 of lambda depending on each case. So lambda is constant throughout, but you could split this one equation up into x, y, and z. So or isn't x or y or z, it's all 3 combined. Okay, so this one is called the vector equation. This is when we want to split it up into its separate parametric equations. Used a lot for solving. And then we can see this last form here, where because lambda is the same in each case, we can relate x, y, and z by just rearranging these so they are all equal to lambda. It's just a rearrangement of this one, and it's something called a Cartesian equation, which kind of ignores, doesn't ignore lambda, it just acknowledges that this multiplier will always be the same number. Always. That scalar multiple. And if we know that that's always the same number, we can kind of ignore it and create a certain number of equations that equal each other, and you can see it there. In this case, well, maybe we'll do it for this case. What would be the first one? What would we write first? X minus 2 over 5. So we rearrange this first one so lambda equals. rearrange this second one so lambda equals. So now I can equate these two. So y minus 4 divided by 7. And z then z plus 1 divided by 2. Okay, and we've created a Cartesian equation.
5, 7, and 2, or 5, 5, 2, and 2?
5, 7, and 2. Yeah.
Why is it called Cartesian again?
Because it's dealing with like a Cartesian x, y, z. That's from a Cartesian plane. So x points x and y and so on. Yes, we're dealing with points. Okay. Let's do an example where we have to turn some information into all these three equations. So we kind of done it here. Let's do it again. Or do you want to? You have a go first, and then I'll do it. So you have a go first. We have a line in space passes through this point. That's a point, not a vector. And in the direction, and they've given it as i's jk, 5j minus 6k. And we want a vector equation. And once we have that, we can get a parametric equation. Once we have that, we can rearrange it to form a Cartesian equation.
So the point is the position vector?
Yes, you could think about it like that, yes. Because it's a position relative to 0, which is just going to be 1 away, minus 2 away, and 3 away. So
R equals the point vector, or 1 minus 2, 3.
So you would start off with, okay, we start off with or. The position is here. This is the only thing we can use for position. 1 minus 2 and 3 plus some multiplier, whatever direction we need to go. So 4, 5, and minus 6. Yes. So yeah, that will give us, that's all possible. We'll give all possible points along. So we turn it into parametric equations to kind of solve for those points. We want to find a particular point along it. We would look at letting R be x, y, z, and then x is 1 plus 4 lambda, y is minus 2 plus 5 lambda, and z is 3 minus 6 lambda. And then I would need to rearrange. Knowing that lambda will be the same for each, we can create a set of equations with just x, y, and z. So we can remove that unknown if it were. So x minus 1 over 4 with a rearrangement, subtract the 1, divide by the 4, is equal to y plus 2 over 5 and z minus 3 over negative 6 is not great, but we can leave it like that for now. Okay?